Okay, so first of all, tell me guys, my audio is clear to you or not? Audible? Am I audible properly? Please confirm this in the chat box. Audio and video both are clear or not to you people? From today, we are going to start a new subject from a very basic, and we will learn this subject in very comprehensive manner. We will solve number of questions in this course, and this is the first lecture. Subject name is Signals and System. You will learn and you will study this subject like never before. I will provide you shortcuts also. First, normal conventional standard method. Using standard method, conventional method, we will solve the problems, and wherever shortcut is possible, short trick is possible, definitely I will provide. Okay, so without wasting time, let us start. First of all, orientation class. Okay, how the classes will be going. Okay, so this is the lecture number 1, introduction to the signals and system. In this class, what we will study, what is signal and different types of the signal based on nature of the variables. Okay, so before starting any subject, what you have to understand, you have to understand the syllabus, total syllabus of this subject. And this signals and system, this subject is common for electrical engineering, electronics and communication engineering, and instrumentation engineering for GATE exam. So these are the syllabus as per the GATE exam for this subject. Representation of continuous and discrete time signals, shifting and scaling properties, LTI system, causal system, Fourier series representation of continuous and discrete time periodic signals, sampling theorem, applications of Fourier transform for continuous and discrete time signals, Laplace transform and Z transform. Here you can see Fourier series representation for the continuous and discrete time periodic signal. That means CTFS, continuous time Fourier series, and discrete time Fourier series, both you have to study for electrical engineer. Similarly, you can see here Fourier transform, correct? Fourier transform for continuous and discrete time signals. That means you have to study DTFT as well as CTFT. The next is Laplace transform, Z transform, RMS value, average value, calculation for any general periodic signal, and this is the syllabus for the electrical engineering. What is the difference between electrical and electronics? Definitely I will tell you. Next, let us see the syllabus, official GATE syllabus for the electronics engineering. Almost the same syllabus, almost same syllabus. Here you can see continuous time signals, Fourier series and Fourier transform, sampling and sampling theorem. In discrete time signals, you have DTFT, EFT, Z transform, discrete time processing of continuous time signals. Then LTI systems, definitions of LTI system, then properties of LTI system like causality, stability, then impulse response, convolution. In convolution, we will study the continuous time convolution as well as discrete time convolution also, poles and zeros, locations, frequency response analysis, group delay, phase delay, each and everything we are going to study. This is the official syllabus for the electronics engineering for GATE exam. Now, here weightage, average, weightage and number of marks. Okay. So, number of questions, last 6 years trend 2017 to 2022 for GATE, number of questions like 2 to 6 questions every year they are asking, and number of marks for electrical 4 to 8 marks, average 6 marks, okay, and range is 4 to 8 marks. These are the frequently asked topics. These are the frequently asked topics in the GATE exam for the electrical. Similar way, for the electronics and communication also. Of course, this is the core subject of ECE, so that's why weightage is more with compared to the electrical engineering. Okay, and level of questions also. So here, if I am talking about the number of questions every year, then average 6 question and range is 4 to 7 questions every year. Marks then 8 to 11 marks, and these are the hot topics you can see or frequently asked topics GATE exam for the electronics and communication engineering. Now next is, this is the complete syllabus as per the syllabus in chapter format, like chapter number 1. So first of all, we will study introduction to the signals and system. These are the chapters of entire syllabus. divided into chapters. Like first is introduction to the signals and system. Then we will study LTI system. LTI stands for the linear time invariant system. Then continuous time Fourier series, continuous time Fourier transform, sampling and sampling theorem, Laplace transform, then discrete time Fourier transform, jet transform, discrete Fourier transform, that is DFT, and discrete time Fourier series, and last is FFT and digital filter. Now this FFT and digital filters only for the IN students. Okay. Here last chapter is not for ECE electrical, for the gate exam, and this may helpful in your semester exams also, and in other exams, in other competitive exams also. Now here I am saying something golden guru mantra. If you want 100% output in this subject, then you have to follow certain steps. Okay, you have to follow certain steps. So first is what? Here I am taking live classes. So you people have to always try to attend the live class, guys. First is what? Always try to attend live class only. And if suppose due to some unavoidable reason you are not attending live class, then before attending next live class, first of all complete all the previous recorded classes. Okay. Then next is full concentration in live class. If I am explaining certain topic, then your concentration should be very much, guys, in live class. Then do not note down while teacher is explaining any concept. Do not note down in between. Then parallel preparation, that is daily preparation. Then next is solve as maximum as possible questions or MCQs, we can say. So solve maximum number of questions. You have to follow these different steps to get 100% output. Then prepare short notes regularly for the revision, of course. Okay, for revision you required short notes also. Then cyclic revision is needed. After completion of one chapter, you can revise that. And again second chapter, you can do the revision. Next is attempt weekly test without fail. Attempt weekly test without fail. Okay. Now what is next, guys? Okay. So if you want to track your preparation, then make a table for this subject. Make a table for this subject. Like here video lecture. If you have completed all the video lectures of chapter number 1, then tick mark here. You have to track in with the help of this table. You can track your preparation. Okay. So if you have completed all the video lectures of chapter number 1, then the tick mark here. Okay. Then class notes. If you have read all the class notes of chapter number 1, then again tick mark here. And if you have completed all the DPPs of chapter number 1, then again tick mark. Similarly, completed UIQs, then tick mark here. Short notes, then again tick mark here. And how many times you are doing revision or you did. Okay, so like only one time, 2 times, 3 times, like that. Okay, and you have to follow these steps in every chapter. So from here, you will come to know that what is your pending work. Okay, and this is very much important, and this is, I think, best strategy, guys. Okay. Yes, this is the full course starting from very basic. Every day 1 hour to 1.5 hour classes will be there. Okay. Now shall we start our first chapter, guys? Tell me. So let us start with very first chapter, that is introduction to the signals and system. And these are the subtopics, we can say. These are the subtopics of chapter number 1, introduction to the signals and system. So topic number 1 is what? What do we mean by signal? What is the basic definition of signal? Then we will see types of signals based on nature of variables. Then later we will see some standard continuous time signals and some standard discrete time signals. Now from here, understand, guys, whatever topic we will study for the continuous time signal all the topics we will study for the discrete time signal, like some standard continuous time signal. In similar way, we will study some standard discrete time signal, like calculation of energy for the continuous time signal. Then we will study the calculation of energy for the discrete time signal also. Like we will study a continuous time convolution. In similar way, we will study discrete time convolution also. CTFS, then DTFS, CTFT, DTFT. Okay. Then Laplace transform for the continuous time signal, and the Z transform for the discrete time signal. Okay. Next is calculate operations. Operations on signals, guys. Different operations on the variables of the signal, like operations on time and operations on amplitude, like time shifting, right shift of the signal or left shift of the signal on the x-axis. Then time scaling, like expansion, time expansion and time compression. Then time reversal, that is the folding with respect to y-axis. Similar way, amplitude, operations on the amplitude, like amplitude reversal, amplitude scaling, like amplification, attenuation. Okay. Then amplitude shifting, upshift or downshift. So these are the different operations that we can perform on the different signal. Again, same continuous time also and discrete time also, guys. Okay. Now next we will study classifications of the signals, different classification of signals, like odd even signal, periodic, aperiodic, causal, non-causal, anti-causal signal, then right-sided, left-sided, bounded, unbounded signals. So these are the various classifications of the signals. Then later, after completion of the signal, we will study what is system, and again classification of systems, guys. Correct? Fine. So now let us start with very first topic. What do we mean by signal? Tell me, guys. What do we mean by signal? What is the basic definition of signal? What do we mean by signal, and what is the basic definition of signal? Tell me in comment box. And I am expecting answer from each and every student in the comment box. What do we mean by signal? If someone is asking simple definition of signal, then what will be your answer? Okay, one student is saying anything which carry information it. Yes, very good. It is correct. Anything which carry information in it. So signal is any quantity having some amount of information associated with it. This is the simple definition. Signal is an any quantity having some amount of information is associated with it, guys. In simple language, see my action of hand and tell me what is the meaning of or what is the information in the action, guys. Okay, okay, just observe my action of hands and then tell me what is the information associated with that in that action, guys. Okay, just tell me. Okay, now tell me what is the meaning of this action. Tell me, guys, what is the meaning of this drama, or we can say action? What conclusion you can get it out from this action? See, again I am doing action. What is the meaning of this action? Tell me, guys, what is the meaning of this action? In a very simple manner, I am going to start this subject and we will go up to the advanced level. Okay, okay, yes, you are right, you people are right. Okay, bring water here, come here. Yes, you are right. So it is an indication. Signal is an indication, yes or no? Like this indication. This action is like one kind of indication. Signal is an indication having some amount of information. So in this indication, some information is there. Okay. Signal is an indication having some amount of information is conveyed from one place to another place. Message or information is conveyed from one place to another place through one kind of indication or one kind of action, guys. So this is a simple definition. Signal is an indication about which some amount of information is conveyed from one place to another place or communicate from one place to another place. This is the simple definition of second definition of signal. First What is the definition of signal? Signal is in any quantity. Signal is in any quantity having some amount of information is associated with it. Or we can say signal is an indication about which some amount of information is conveyed from one place to another place. Or we can say signal is a function. In mathematics, signal is a function of one or more independent variable. Function is a function of one or more independent variable. So these are the various definitions of the signal. So here, see the first definition. What do you mean by signal? The basic interview question also. If you are saying that signals and system is my favorite subject, then they can ask a very simple question. What is the basic definition of signal? So you can say signal is any quantity having some amount of information associated with it, or we can say signal is an indication about which some amount of information is conveyed from one place to another place. One more definition is there. It may also be defined as function of one or more independent variables. Now here variables come in, guys. What do you mean by variables? What do you mean by variable? While defining signal mathematically, we are considering two types of variables. One variable on the y-axis and another variable on the x-axis. Two-dimensional signal. Here I am talking about the independent variables or variables. So there are two types of variables for the signal. One variable on the y-axis and one more variable on the x-axis. Okay, so two-dimensional signal. Fine. Any doubt in this definition of signal? Tell me, guys. Any doubt in this? Any doubt? Any doubt in this definition? Understood? Fine. Okay. So let us continue further. Now, what I am saying, guys, see, these are the basic examples of the signal. Like voltage signal can be represented by voltage across any element varying as a function of time, guys. Voltage across any element, like voltage across resistor, as a function of time. So with respect to time, voltage is varying. See, you can see here, this is a sinusoidal AC signal, voltage signal. So here on x-axis, this is the variable time. So this time is varying, that's why variable. Okay, time is varying, guys. But it is an independent variable. You can take any value of time. Here this variable does not depend on any further variable. So that's why on x-axis, we are considering or we are drawing the independent variable, and in the most of the case in this subject we will take time as an independent variable on x-axis. Okay, in the similar way on the y-axis, dependent variable, because on y-axis we can say amplitude of this signal depends on this time. So on y-axis dependent variable, and in this case it is a voltage depends on this time. Okay, so on y-axis voltage, or we can say amplitude of this voltage, like we can say this is the peak amplitude, maximum amplitude. At this time you are getting maximum amplitude. Here positive peak, you can say this is, you can say at this time you are getting negative amplitude, minimum amplitude. Okay, so this is the example of the basic example of signal, voltage signal. So voltage signal is nothing but what? Voltage across any element varying as a function of time. And here, from here to here, this is known as peak to peak value. This is the maximum peak, this is the minimum peak, peak to peak value. Okay. One more example is there. Speech signal would be represented as the acoustic pressure as a function of time. Speech signal would be represented as acoustic pressure as a function of time. You can see here as a function of time. So on x-axis again independent variable time. Okay, and with respect to time, acoustic pressure is varying, and we are marking the acoustic pressure with respect to time on the y-axis. So you can see here on y-axis pressure, scale is pressure, guys, like 0, 1, 2, and on x-axis time, and this is the, we can say, output of this speaker. Okay. So acoustic pressure as a function of time. So again I am telling guys that with signal there are two types of variables. One we are drawing on x-axis, which is nothing but we are considering time, and on x-axis we will mark amplitude of the signal. Like voltage signal, so voltage is amplitude. Like speech signal, so acoustic pressure is amplitude, acoustic pressure. Okay, see, this one is what? Amplitude of this acoustic pressure, correct? Like 1 volt, 2 volt, then here 1 Pascal, 2 Pascal and 3 Pascal and so on guys, correct. So here now you can see guys, types of signals based on nature of variables, guys, types of signals based on nature of variables. Okay, now you can see here signal, I'm simple writing. So there are two types of variable as I told. One is independent variable on x-axis, and we will consider time. See, not always time guys, but in your syllabus variable we are considering in standard book also time guys. So independent variable on x-axis, variable is nothing but time t, and here dependent variable on y-axis, that is the amplitude guys, amplitude of the signal, correct. Now here important, what is the nature of variable? Here I am saying, every time I am saying guys, nature of variables, that is the nature of time and nature of amplitude. So here this time can be continuous and it can be discrete also. Okay, this time can be continuous and it can be discrete. So depending on that, there are two types of signal based on the nature of time, continuous time signal and discrete time signal. Here the time will be continuous and here the time will be discrete. In detail also I will tell you. In the similar way, this amplitude can be continuous amplitude, it can be discrete amplitude. So put together, here two possibility, here two possibility. On x-axis two possibility, it can be continuous time, it can be discrete time. On y-axis there are two possibilities, it can be continuous amplitude, it can be a discrete amplitude. So tell me how many total types of the signal based on nature of variables guys, like continuous time, continuous amplitude signal. In this manner, how many types of signal based on nature of variables, tell me in comment box total. Tell me guys, how many types of variables? And I am expecting answer from each and every single student. How many types of variable based on the how many types of signals based on the nature of variables? So yes, of course, few people are saying there are four types of signals based on nature of variables. Okay, first we can say continuous time and continuous amplitude signal. Second we can say discrete time and continuous amplitude signal. Third we can say continuous time and discrete amplitude signal, and fourth is discrete time and discrete amplitude. So I will explain each and every type with different examples. Okay, fine. Let us continue guys. So first of all, you have to understand what do you mean by continuous time and what do you mean by discrete. Continuous time means what? Continuous time is what? Signal amplitude is exist for any instant of time. Any instant of time, signal amplitude is available, whether it is 0 or non-zero, but any instant of time you can find the amplitude of the signal, or we can say amplitude of the signal is defined at any instant of time for the continuous time signal. Correct? Are you getting what I am saying? Continuous time signal amplitude is defined at any instant of time. That time t you can take integer value also, non-integer value also, positive also, negative also. You can find, or amplitude is defined for t equal to 1.5 also, t equal to 2 also, t equal to minus 2.56798 also, correct? Even t equal to minus 3 also. So here in continuous time on x-axis, this time t can be integer or it can be non-integer also guys, correct? Integer, non-integer both are allowed in the continuous time signal. Whether in discrete time, only integer values of time is acceptable because of the sampling. Only discrete value of time is acceptable. Simple example I am giving, very simple example I am giving. Tell me guys, here this flashlight is visible or not? Tell me guys, can you see this flashlight? Mobile phone, can you see this flashlight in mobile phone? Now tell me, the intensity of this flashlight is continuous or discrete? Simple, tell me guys. the intensity of this flashlight. Now, as of now, the intensity of flashlight is continuous or discrete? Well, tell me guys, you are getting continuous intensity of this flashlight or in discrete manner? Tell me in comment box. I am expecting answer from each and every student. I am expecting answer from each and every student. Yes, of course, intensity of this flashlight is continuous, because continuously you are getting the intensity at any instant of time. You can measure the intensity of this flashlight, whether it is the integer value of time or this non-integer value of time. Now tell me, now see the operation and tell me you are getting continuous light or not, or continuous intensity or not. Now tell me guys, see this observation and see this operation. I am pressing on button for every 2 seconds, like t equal to 0, then t equal to 2, then t equal to 3. Now tell me guys, in this observation, intensity of light is continuous or not? Tell me guys. Okay, previous observation. Now tell me, intensity of light is continuous or not? No. In the second example, we are getting intensity of light for the discrete value of time. Like first at t equal to 0, switch on, then you are getting light of intensity of light. Then at t equal to 2 seconds, you are getting again intensity. Then again at t equal to 4, then t equal to 6. Okay, so you are getting samples guys, samples. So this is an example of discrete time signal. Okay, in similar manner, continuous amplitude signal, in which infinite number of amplitudes are possible. Infinite number of amplitudes are possible. Like we can say between 0 and 1, how many numbers are possible? So we can say infinite numbers are possible between number 0 and 1. So in continuous amplitude, infinite number of amplitudes are possible, but in discrete amplitude signal, there are finite number of amplitudes. Now, like any instant of time, any 4 amplitude is possible, like -2 or 0 or 1 and 2. Okay, so let us understand this in detail guys, in detail. Okay, see here, now continuous time signal. So as I told guys, here this is the mathematical representation of the signal. X is a signal, and here t guys, in bracket we are writing this is independent variable guys. T is independent variable. So this t independent variable, it can be an integer or it can be a non-integer. So in continuous time signal, signal amplitude is exist or defined for any instant of time. Here signal amplitude is defined at any instant of time. This time can be integer or it can be non-integer. And in discrete time, signal amplitude is defined only for the discrete value of time guys, at discrete value of time. So here signal amplitude is exist or defined only for discrete value of time, correct? So here in discrete time signal, only integer value of time. Here this t stands for the independent variable on x-axis, and here this n also guys. Here this n also. So guys, what? Independent variable time, but notation is n for the discrete time signal and notation is t for the continuous time signal. Here round bracket and here the square bracket guys. So this is the discrete time signal. Okay, this is the representation of discrete time signal. Square bracket and independent variable on x-axis is n, and which is integer only, like 0, 1, 2, 3, 4, -1, -2, -3, 4 only guys. And here this is what guys, continuous time independent variable, it can be integer or it can be non-integer also guys, correct? Integer or non-integer, fine. Yes, I am explaining continuous amplitude signal also, don't worry. Continuous amplitude signal also, don't worry. Okay, is this clear? Any doubt in this? What is the meaning of continuous time signal? And what is the meaning of discrete time signal? Any doubt? Any doubt in this, guys? Mathematical representation graphically also I will tell you guys. Any doubt? First of all, tell me in continuous time signal, discrete time signal, basic definition. Okay, so let us continue further. Now here continuous amplitude signal and discrete amplitude signal. Here A into x of t, guys. A into x of t. So whatever variable associated with x of t is nothing but A, and this A indicates amplitude of this signal. Amplitude of this signal. Amplitude can be variable, it can be also. So here A. So A is nothing but what? Infinite number of amplitudes are possible. Infinite number of amplitudes are possible. In simple way, I can say, simple example, I am drawing here exponentially decreasing function. For exponential decreasing, here I am writing x of t, and just to see this signal, tell me guys, just to see, tell me here. Here this is 1, and here at t equal to infinite. Suppose t equal to infinite, amplitude is 0, guys. Then this signal at t equal to 0, amplitude 1 and t equal to infinite, amplitude is. So as t varies from 0 to infinite, amplitude is varying from 1 to. So between 1 to 0, tell me possibilities of amplitudes, number of amplitudes. How many number of amplitudes are possible from 1 to 0, guys? Here amplitude is 0. Here amplitude is 0. So tell me guys, how many number of amplitudes are possible? Number of points or number of amplitudes are possible from 1 to 0, or we can say from t equal to 0, t equal to infinite. As we are moving from t equal to 0 to t equal to infinite, tell me number of amplitudes. Tell me how many number of amplitudes are possible here. How many number of amplitudes are possible in this case if we are moving from t equal to 0 to t equal to infinite? Tell me guys. Tell me infinite or finite possibilities. Of course, infinite possibilities. Like here 1, then next point can be you can take 0.999998, then you can take 0.99995 and so on, guys. So of course there are infinite number of possibilities, infinite number of amplitudes. Here infinite number of amplitudes, as I told you guys, there are infinite number of amplitudes in the continuous amplitude signal, whereas in discrete amplitude signal there are only certain range of amplitudes. At any instant of time, out of that range you will get only one amplitude. That means see here. And what is the process of converting continuous amplitude signal into discrete amplitude signal? That also I will tell you. Quantization process. Now observe this signal. Just observe. Okay. So this is t equal to 0. Suppose this amplitude is 1, amplitude is 2, guys. Okay. Here amplitude is -1, amplitude again 1, and suppose this is 0, 1, suppose this is 3, 4, and this is. Now tell me, as you are moving from amplitude here, this is amplitude. Now in this case, if you move from t equal to 0 to infinite, if you move from t equal to 0 to infinite, amplitude can be, it can be either 1, amplitude can be 1, or it can be 2, or it can be -1, or it can be 1, guys, or it can be 0. Yes or no? So amplitude can be, it can be here, not infinite number of amplitudes are there. Here it can be 1 at any instant of time. Amplitude can be 1, it can be 2, guys, it can be -1, it can be 1 again, or it can be 0, guys. So among these 4 amplitude, only one amplitude is possible at any instant of time, yes or no? This can be integer or it can be non-integer. Amplitude can be integer or it can be non-integer. Don't worry guys. Amplitude can be integer or it can be non-integer. But out of this range only, you will get amplitude at any instant of time. At any instant of time, you will have amplitude out of this range guys. Among these 4 amplitude possibility. So here number of amplitudes are finite guys. You can see either it can be 1, it can be 0, it can be 2, it can be -1 as we are moving from 0 to infinite. Yes or no? Now you got the difference between continuous amplitude and discrete amplitude signal. Yes or no? Tell me guys. Did you get this difference between guys? Tell me. Is this clear to you people? Is this clear guys? What is the difference between continuous amplitude signal and discrete amplitude signal? Here number of amplitudes are infinite. Infinite number of amplitudes are possible. At any instant of time, different amplitudes are getting. But here out of only 4, this is the example. But only finite number of amplitudes. Is this clear now? Now got it? Fine? Okay. So let us see in detail guys. So as I told you guys, there are 4 types of signal based on the nature of the signal. So first is what? Continuous time and continuous amplitude signal. Simple, I am taking one example. When I am taking an example guys, x of t, suppose x of t exponential decreasing function I am writing. Detail also I will tell you guys, e power -2 u of t into u of t. So this is the mathematical representation of any signal guys. Random signal I am taking, e power -2t into u of t. This is the mathematical representation. Okay, what is u of t? Unit step function. Later we will see. You just understand this u of t indicates only for the positive value of time guys. So if you draw graphically, as you multiplied e power -2 u of t, so u of t indicates only for the positive value of time. For t less than 0, amplitude is 0. Later we will see, don't worry. Just remember, for t less than 0, amplitude is 0 guys. For t less than 0, amplitude is 0. Now tell me, what is the amplitude at t equal to 0? And I am expecting answer from each and every single student in comment box. At t equal to 0, what is the amplitude? So if you put t equal to 0 in this function guys, or signal x of t, this is the representation of continuous time signal. So x of 0 guys, x of 0, what will be the amplitude? So e power 0 guys, power 0, e power 0, u of t is 1, so it will be 1 guys. At t equal to 0, amplitude is 1 guys, correct? Amplitude is 1. And as t increases guys, tell me, amplitude as t increases in positive direction, amplitude is decreases or increases? As you increases for t greater than 0, tell me, for t greater than 0, like at t equal to 1, what will be the amplitude? X of 1 guys, what will be the amplitude of signal? So e to the power which is 1 guys. And in similar manner, as you increases t in positive direction, as you are moving from t equal to 0 to infinite, amplitude is decreasing exponentially. Amplitude is decreasing exponentially from left to right, and at t equal to infinite, finally at t equal to infinite, the amplitude will be e to the power minus infinite, amplitude will be 0. Amplitude will be 0. And here I am taking any value of t guys. Here in this you can take t integer or non-integer, both are valid. You can take the integer value of t, or you can take non-integer value of t also. You can take t equal to 1.5 also. You can take t equal to 1.256 also guys. In short, in this, amplitude is defined for any instant of time guys. For any instant of time. So here amplitude is decreasing, gradually, exponentially decreasing guys. And finally, at t tends to infinite, amplitude will be 0. Okay. So this is exponential decreasing function. Now tell me here, time is continuous or discrete? Can you get guys? Can we get amplitude at any instant of time? Yes, we can get the amplitude any instant of time. So that's why this is the continuous time signal. Now tell me here, number of amplitudes from 1 to 0 here at t equal to infinite. At t equal to infinite guys, t tends to infinite or t equal to infinite, amplitude will be 0. So from 1 to 0, how many number of amplitudes are there? Number of amplitudes. So as we can see guys, from 1 to 0, there are number of amplitudes are possible, and whenever number of amplitudes are possible, then it is what? Continuous amplitude signal. So here time also continuous and amplitude also continuous. On x axis you have to mark x of t. This indicates here on y axis amplitude, guys. Okay, on y axis amplitude, on x axis time t, guys. On x axis time t, it can be negative amplitude also possible. Negative amplitude also possible. Amplitude can be integer, it can be non-integer also. Remember this thing. Amplitude can be integer, it can be non-integer also. Correct? So here number of amplitudes are infinite. So that's why continuous amplitude signal and time is what, guys? Time also continuous. So it's a continuous amplitude. This is the example of continuous amplitude, continuous time signal. Here time is on x axis, time is continuous and amplitude on y axis, amplitude of the signal also continuous, guys. Now the very much important topic, how to convert. Is this clear? This is the simple, guys. This is very much simple. Now see here, how to get discrete time signal from the continuous time signal, or how to convert continuous time signal into the discrete time signal. My question is what? How to convert continuous time signal into the discrete time signal. See here, what process you have to perform so that the continuous time signal can convert into the discrete time signal. So this is the simple example. Again I am showing. Observe the intensity of this light, guys. So as of now, we are getting intensity of light continuously. At any instant of time, we can measure the intensity of this flashlight. But if you want this intensity discrete manner at certain value of time only, like you want intensity at t equal to 0 or every duration of 1 second or every period of 1 second, like you want intensity of light at t equal to 1 second, then next at t equal to 2 second, then next you want t equal to 4 second, then next at t equal to 6 second, then what operation you have to perform? See, here there is a button, guys, to on off this flashlight. There is a button to on off this flashlight, or we can say there is a switch. There is a switch. With the help of that switch, we can turn on the light and turn off the light. So what I am going to do at t equal to 0, this is off, guys. Okay, so let us consider amplitude is 0. T equal to 0, I am pressing this button, turn on the light, then again turn off. After t equal to 2 seconds, again I am turn on the light, then again for 2 seconds turn off the light, then again at t equal to 4 seconds just turn on the light. So in this process, turn on, then again off, switch on, switch off, switch on, switch off. In this process, actually what we are doing is, so we are collecting samples for a certain duration of time, and that duration is fixed. We are collecting samples of output, we can say. We are collecting samples of this intensity of light at a particular duration of time, guys, at a particular period of time. Like first sample, you are collecting first sample at t equal to 0, then you are collecting sample at t equal to 2 seconds, then again you are collecting sample at t equal to 4 seconds with the help of this on off switch, guys. On off switch which is periodically on off, guys, periodical on off. So what you have to do, guys, so this is the continuous time signal. Now next is discrete time and continuous amplitude signal. So if there is a continuous time signal, suppose the continuous time and continuous amplitude, just example, see here, here's example, x of t equal to e to the power minus 2 of t. Now in this signal, what you have to do, the process called sampling process. You are collecting the samples at a particular duration of time. This process is known as sampling process. So here, see, what is the sampling process? What exactly you people are doing here? This is the continuous time signal, guys. Continuous time signal. Here t can be integer, it can be non-integer, but in between you are keeping, guys, and this switch continuously on off, guys. This switch through which we are collecting this, and here output your discrete time signal x of n. Now what exactly we are doing, guys? Suppose this is the signal, continuous time signal. Just an example, x of continuous time signal. continuous time signal. Suppose this is starting point 0 and this is 10 guys, 10. Okay. Now you are taking first sample at t equal to 1 second. You are taking first sample at t equal to 1 second. T equal to 1 second, you are taking the first sample, or t equal to 2 seconds. You are taking first sample at t equal to 2 seconds. T equal to 2 seconds, you are taking first sample. The first sample that you are taking at t equal to 2 seconds. Then next, you are taking the sample at t equal to 4 seconds. 4 seconds. Next sample, you are taking at t equal to 6 seconds. Okay, sampling period. Sampling period, you are taking sampling period is 2 seconds guys. 2 seconds sampling period. So sampling period is what? Period between two samples guys. Duration between turn on the light and turn off the light guys. Correct? Okay. So duration between two samples is known as sampling period. So we are taking first sample at t equal to 2 seconds, the next sample at t equal to 4 seconds, the next sample is t equal to 6 seconds, and this sampling period is fixed guys. Cannot vary this sampling period. Okay. The next sample is t equal to 8 seconds, and last sample is at t equal to 10 guys. T equal to 10. So here TS is a sampling period. TS is a sampling period, and inverse of this TS is nothing but sampling frequency. Inverse of this sampling period is nothing but sampling frequency, samples per second. Okay. So here Fs I am writing, Fs is nothing but 1 upon Ts, which is nothing but sampling frequency. Sampling frequency. So unit of sampling period is second. Then unit of this sampling frequency is what? Samples per second. In 1 second, how many samples you are collecting or you are taking? Number of samples you are taking for 1 second or per second. So unit you can write samples per second. Or you can take unit hertz also guys, because this is the frequency Fs. So you can take unit hertz also, or samples per second also. Number of samples you are collecting for 1 second. Okay. So here tell me guys, now relation. What is the duration of this signal guys? Total duration of x of t. What is the duration guys? I can say 10 seconds, for which amplitude is non-zero. From 0 to 10 signal is defined, or signal amplitude is non-zero between 0 and 10 guys, between 0 and 10 for x of t. Okay. And here you are taking the sampling period. Yes, is equal to second. Sampling period Ts equal to 2 seconds. That is the period between two samples. Now tell me, with this data, how many samples you will get? Sampling process. Number of samples. Tell me. Number of samples. How many number of samples you will get? N. Number of samples guys. Tell me number of samples. How many number of samples will you get in this? Tell me in comment box, everyone. Number of samples. Number of samples, tell me guys. Yes, very good. 5. 5 number of samples will get guys. 5 number of samples. Sampling period Ts, or I can write capital Ts also. Correct? Because fundamental time period capital T. Sampling period is capital T also. So notation capital Ts I am writing. Now tell me, what is the relation between these three variables or three quantity? Relation between this small t time signal, small n is a discrete time signal, or we can say discrete time, or we can say number of samples also, and this is the sampling period. So the relation will be, you have to simply replace t with t, replace t with what? N into t. To replace this t in continuous time signal, if you replace this t with n into ts, then you will get the discrete time signal. Discrete time signal. Okay. So simply you have to replace this t with n into ts, guys. When n, you will get number of samples. This can be integer. Now tell me, this n can be only integer value, guys? It can be only integer, guys. No integer possible. Number of samples 5.5 samples. Is this possible? 5.5 samples, 5.2 samples. Number of samples are 5.2. Is data possible? No, guys, not possible. So here number of samples always integer, guys. Always integer. Can be, it should be always integer, guys. So t equal to nts, t equal to nts, guys. Okay. So here also I am writing simply you have to replace t with nts, guys. You have to replace simply t with n into ts, where t is a sampling period, okay, which will be given in the question, and n is number of sample, guys, which is only integer. Integer only, guys. Correct? So here continuous time signal x of t is equal to e to the power minus 2 into u of t. Simply in this, simply replace t with n into ts, then you will get the discrete time signal. You will get the discrete time signal. And for simplicity, in entire syllabus we will take sampling period by default 1 second. To take sampling period 1 second, then you will get sample at t equal to, suppose if ts is equal to, if sampling period ts is equal to 1 second, then sampling period ts is equal to 1 second, then n is equal, then t equal to n, guys. But n is integer value, guys. Then here x of n will be the power minus 2 into 2 of n, but here n only integer value of n is here. This t can be integer, but it can be non-integer. You will get amplitude at any instant of time. But after sampling process, if you replace t with nts, and if ts equal to 1 second, suppose for simplicity, then x of n equal to e power minus 2 into u of n, then this is what, guys? This is the discrete time signal. This is what? Discrete time. dt means discrete time signal. And in this, variable is independent variable is n on x-axis, and n is one integer value. Okay. So this process is known as the sampling process. Process of converting continuous time signal into the discrete time signal. Process of converting continuous time signal into the discrete time signal. This process is known as the sampling process. Okay, and simply you have to replace t with nts. Okay, if ts is not given, then take ts sampling period 1 second. Okay, here. So after sampling, guys, how this signal look, guys? After sampling, here replace t with nts in the t is equal to n into ts, n t here, guys. So n into 2, then now it is converted into discrete time. X-axis capital N, here x of n, guys. This continuous time signal y-axis x of t, and here x of n, here n, guys. And this is only integer values are valid here, only integer values. So at t equal to 2 second, guys, suppose n equal to 1 I am taking. Okay. So first sample at t equal to 2 second, the representation of discrete time signal. The representation of discrete time signal. So these are the discrete time signals, the representation of discrete time signal. The vertical line and here dot. So we can take amplitude as here see. Then first sample at second, 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 second. Okay. So if you replace t with n, then you will get this one. Correct? Only 5 samples. So 1, 5 samples here and here. Here now we got x of is equal to the power minus of n. Correct? Graphical representation of this. Now here only integer. Sampling period is 1. It is 1. So let us consider you are taking first sample at t equal to 0. T equal to 0, first sample at t equal to 0. This is the sample, guys. T equal to 0. The next sample is at t equal to 1 second. Suppose t equal to 1 second. By default, sampling period 1. Next sample at t equal to 2, guys. And next is at t equal to 3. Then next t equal to 4, 5, so on, guys. Correct, and so on. Fine. Correct. At n equal to 1, it is 1, guys. Amplitude is 1. At n equal to 0. At n equal to 0, amplitude x of 0, guys. X of 0 is nothing but dot e power 0, 1, guys. At n equal to 1, next only integer value, guys. So x of 1, guys. X of 1 is e power minus 1. N equal to 2, guys. N equal to 2. So x of 2, so e to the power minus 2. Similarly, here n equal to infinite, guys. N equal to infinite. X of infinite, that is the power minus infinite. Sample amplitude. Okay, at the last at n equal to infinite, amplitude is 0, guys. Amplitude is 0. Here amplitude is e to the power at n equal to 1, 3, 4, 5. Sampling period is 1 second. Sampling period is nothing but the period or duration between two samples. So e to the power minus 1 and e to the power minus 2, e to the power minus 3. So here time is what? Discrete time. Time is discrete. Tell me, what about amplitude, guys? Amplitude is continuous or discrete here? 1, e power minus 1, e power minus 2. How many amplitudes are possible as you are moving from n equal to 0 to infinite? As we are moving from n equal to 0 to infinite, tell me number of possibilities of amplitude, guys. Number of possibilities of amplitude. How many amplitudes are possible? Again you can see 1, e power minus 1, e power minus 2, e power minus 3, e power minus 4, up to e power minus infinite. So there are infinite number of amplitudes. Again you can see, guys. Again you can see, guys. Infinite number of amplitudes. Again number of amplitudes are infinite in this case also. Only time is discrete. So again we can say this is what, guys? Discrete time and continuous amplitude. This is the example of. This is the example of discrete time. Discrete time and discrete time and continuous amplitudes. Clear? Is this clear? Difference between is the discrete time signal and this is continuous time signal. Here, exponential decay. This is what? Continuous time signal, you can see here, and the example of discrete time signal. Fine? Here. Now what is next? Next is what? Continuous time and discrete amplitude. Okay. So just we have seen the process of converting continuous time signal into the discrete time signal, and this process is known as sampling process. In the similar way, now we will see, now we will convert continuous amplitude signal into the discrete amplitude signal. This process is called the quantization process. Okay. So continuous time and discrete amplitude signal, continuous time and discrete amplitude signal. So just observe this thing. Just see example and tell me the continuous time, discrete time, what? I am taking this sinusoidal signal. Consider this sinusoidal signal. Here amplitude is 8 and here amplitude minus 8. So peak amplitude, maximum amplitude is 8. Here minimum amplitude is minus 8. So from 8 to minus 8, how many number of amplitudes are possible from here to here? From 8 minus 8, from this point to this point, from 8 to minus 8, how many number of amplitudes are possible? Number of amplitudes, tell me. Tell me number of amplitudes from 8 to minus 8. Number of amplitudes are, tell me number of amplitudes from 8 to minus 8. So of course, you can see here, infinite number of amplitudes are possible between minus and 8, guys. Between minus and 8, infinite number of amplitudes are possible, yes or no? It is a continuous amplitude and continuous time signal. Time is also continuous and amplitude also continuous. Now how to convert this continuous amplitude signal into the discrete? So there is a quantization process for this quantization process. In quantization process, you have to do type of leveling, guys. Type of level. Special circuit is available for this quantization. So you have to just concentrate on the process. So 4 level, 1, 3 and 4. 1, 2, 3 and 4. 4 levels are there. So here continuous amplitude like 0 volt, guys, then 8 volt, 4 volt. Number of levels are depending on the application of the application. Depends on the application. Number of levels, you can take 4 levels, you can take 6 levels, power n, guys. Then n is number of bit, later you will see. So here, so what is exactly this quantization process? Here also, well, here this is, guys. Next is minus 4 here, minus 4, minus 4. Now see, if your amplitude, what is the meaning of this learning? If your amplitude in this signal, if amplitude of this signal lies between 0 to 4, then you have to take average value, that is 2, guys, 0 to 4. So whatever amplitude lies between 0 to 4, in output you will get average of 0 and 4. That means you will get 2, guys. You will get 2 here. Correct? Whatever amplitude present between 0 and 4, whatever amplitude present between 0 and 4, in output you will get amplitude 2, guys. Get amplitude 2. Correct? Like this. So output will be like this. Output will be like this. Here, if input present between, or here amplitude present between 0 and 4, output will be for this range, for this input range, output of the sampler circuit will be 2 volt only. Okay, so input present between 0 and 4, output of the circuit will be 2 volt only, guys. Whatever input lies between 0 and 4, output will be 2 volt, guys. Output will be 2 volt or 2 only, guys. 2 volt or 2 only if this is the voltage signal. In the similar manner, if input present or amplitude present between 4 and 8, the output of the circuit will be, we can design this kind of circuit. We can design this kind of circuit, input present between 2 and 4, then output will be correct. So here input present between 0 and 4 and 8, the output will be 8 only, whatever input is. Whatever amplitude of the input is there, output will be always average of 4 and 8, that is 6. Again for this range, guys, again between 4 and 8, again between 4 and 8, output will be 4 only, guys. Output will be 4 only. Similarly, between again between 0 and 4, guys, between 0 and 4, output will be 2 only. Output will be 2 only. Now between 0 and minus 4, guys, between 0 and minus 4, output will be minus 2. Similarly, between minus 1 and minus 8, output will be minus 6, guys. This is called quantization process, converting continuous amplitude into the discrete amplitude. Here minus 2. So whatever amplitude present between 0 and minus 4 for this range, sorry, here fine. So between 0 and minus 4, output is minus 2, guys. Output is minus 2. Then again minus 4 and 8, minus 4 and 8, output is minus 6, guys. Correct, output will be minus 6. Then again minus 4 and minus 8, output will be minus 6. Then again 0 and minus 4, guys. Consider 0 and minus 4. Put 0 and minus 4, output will be minus 6. Correct, minus 6. Then make continuity like this, connect all the points. And you can see here. Now tell me, finite number of amplitudes are possible or only finite number of amplitudes are possible at any instant? At any instant of time. Tell me, guys, infinite number of amplitudes or finite number of amplitudes, guys, tell me, at any instant of time. Now you can see here, again, see, input present between 0 and 4, here output is 2 only. Then next, between 4 and 8, here 6, can be 6, again here this is 2, here between minus 4 and 0, minus 2, and this is minus 6, minus 6, minus 2. Now suppose this is 0 and this is suppose 10 seconds. Here also this is 10 seconds, this is 0, guys. So in this case, in this you can see from here, in this signal, from 0 to 10, guys, infinite number of amplitudes are possible. From as you are moving from 0 to 10, here infinite number of amplitudes are possible. But in this case, as you are moving from 0 to 10, amplitude can be either 2, it can be 6, it can be 2, it can be minus 2, it can be minus 6, or it can be minus 2. Okay, amplitude can be minus 2, it can be, guys, it can be 6, it can be minus 6. Only out of 4 possibilities, there is only one amplitude. Yes or no? So this process is known as the quantization process. Now we got guys, how to convert continuous amplitude signal into the discrete amplitude signal. This process is known as quantization. ये जो process हुआ है, this is quantization. Process of converting continuous amplitude signal into the discrete amplitude signal is quantization process, and process of converting continuous time signal into the discrete time signal is known as sampling process. Fine. Now last is what is the last, guys? Continuous amplitude and discrete amplitude signal. So first sampling process, then quantization process. So you will get what? Continuous amplitude and discrete amplitude and discrete time signal, like this. Example is, if you do the sampling of this signal, if you perform sampling process in this signal, then you will get what, guys? You will get the discrete amplitude or discrete time signal. Example will be like this. Example, tell me here, amplitude and time both are discrete or not? Amplitude and time both are discrete. In this case, amplitude and time both are here. Let us consider this is 1, the only integer values. So you can see signal is not present between 1 and 2. Similarly, signal is not defined between 2 and 3, not defined between 3 and 4. Here signal amplitude is defined only for the integer values of n, guys. Only integer values of n, like 8, 9, 10, then 11. Negatives are also correct. Well, in this, correct. Amplitude is like, it can be 2, it can be 6 again. 6, 6, 6, 6, can be -2, can be -6. So this is the example of discrete time and discrete amplitude signal. Is this clear now? Is this clear? 4 types of signal based on the nature of the variables. Nature of the variables, guys. There are 4 types of signal: continuous time, continuous amplitude signal; discrete time, continuous amplitude signal; continuous time, discrete amplitude signal; and last one is discrete amplitude, discrete time signal. Okay, these are the basic types of the signal based on the nature of the variables. So what is the conclusion finally? What is the conclusion? So what is the sampling process? This you have to write in short notes, guys. How to convert continuous time signal, discrete time signal? The process called sampling process. The process of converting continuous time signal to discrete time signal. CT stands for the continuous time. Simply replace T with NTS. Switching process is there. Simply replace with N into TS. Sampling period will be given the question. If it is not given question, then take TS equal to 1 second. By default, we are considering TS equal to 1 second, so that on x-axis you can get 0, 1, 2, 4, 5. It will convert into what, guys? X of n with time signal. Continuous time signal. This, let me mark here. This is the continuous time signal. If you replace T with NTS, then it will convert into the time signal. Where what is TS? TS is a sampling period in second. TS is a sampling period in second, and it is the inverse of the sampling frequency. It is inverse of sampling frequency, and fs is a sampling frequency in hertz, or unit is samples per second. Number of samples per second. How many samples you are taking for 1 second, in 1 second. Now what is the quantization process? So it is a process of converting continuous amplitude signal into discrete amplitude signal. The final conclusion lecture, guys. Process you have to understand. What it? Process of converting continuous amplitude into the discrete amplitude signal. Is this clear? Is this clear to each and everyone? Tell me. Now some feedback I want. his speed of teaching is fine? Tell me guys, can we go with this speed, or I need to increase the speed or decrease the speed? Tell me guys, tell me feedback. One more feedback, his presentation is clear, neat and clear. Tell me, is this visible in your screen? Is this type of presentation is visible in your screen, or I need to improve this presentation? Tell me, you are comfortable with this presentation? Some feedback I want, so we can get the best output of this session or of this series guys. So let us finish this lecture here, or let us stop this lecture here. Now from next class we will study some standard signals, some elementary signals. With the help of this standard signal, we can draw or we can graphically represent complex signal. Okay, so let us finish this lecture here guys, and please provide your valuable feedback. Okay, so guys, thank you so much watching me live on Get Wallah English channel, and next part we will continue in subsequent module. Thank you guys, thank you so much.